The commercial space industry is taking off rapidly with advances across all aspects of the industry. And June, at Pale Blue, you've developed a water-based propulsion system that's an alternative to the traditional xenon or hydrazine-based systems that use explosive propellant. What are the advantages of a water-based propulsion system?
Yeah, as you know, the traditional propulsion system uses toxic propellant such as hydrazine or the very rare propellant such as xenon. And for the hydrazine, it's very dangerous for the human to treat the propellant, and which leading to the very high cost. And also xenon is a very rare resources, so now it's difficult to get the energy resource. So that's why we are focusing the water propellant, water engines. As you know, the water is very safe, and also it's the most affordable energy resource on the Earth. So by using water as a propellant, we can make a new propulsion system, new mobility solutions for the commercial satellite.
It seems so incredible to think about water working to power a spacecraft. So can you walk us through how that works, that water becomes a thrust for a spacecraft?
It's not difficult. I think it's simple. We have a new...
It is rocket science, Jim, so it's not easy.
It's actually rocket science, yeah. But we have a new two types of water engines. One is a water resistor jet, and the other one is a water ion thruster. A water resistor jet using steam to generate thrust to move satellites. We heated up water to make a vapor, make a steam, and then eject the steam to the space to move the satellite in space. And water ion thruster is a bit complicated. The process of making steam is similar to the water resistor jet thruster. But in addition, we are using a unique technology by using a microwave and magnet to generate water plasma. And then we eject the water plasma to generate thrust. It can achieve 10 times higher efficiency compared to the water resistor jet thruster.
So both of these are self-contained propulsion units that would go into a small satellite, for example, along with water. And in one example, you've done a successful deployment with Sony with just 250 milliliters of water. How does so little water enable you to power a spacecraft?
We succeeded in the operation in space on board the Sony satellite I, and it's a major milestone for our company. And our engine stored the water inside the tank. Then after the launch, we use a small amount of water to generate thrust. The thruster can provide thrust performance as we expected, and we can prove that our propulsion technology can be alternative engines for the traditional propulsion system.
And what is the cost of the Pale Blue propulsion unit versus a xenon or hydrazine one?
Our water engine is half cost of the traditional engines that uses hydrazine or xenon.
Aside from also just the environmental impact being far less, given how safe water is, but then also the safety benefit for humans as well. Do you think that there's a motivation within the commercial space industry to become more environmentally sustainable?
Yeah, I think it's difficult for not only on the Earth, but also the space development. Right now, for example, the space debris becoming a big issue for space development.
Yeah, debris through so many fragments orbiting currently.
So sustainability is also important for space development, and also our water engines can contribute to the sustainability in space.
June, you've developed a collaboration with the Japanese Space Agency. What are the elements of that partnership?
Right now, we have a collaboration research development with Japanese Space Agency, JAXA. And JAXA already have a technology for the propulsion system for larger satellite, big satellite. And right now we are focusing on the small satellite and the water engine technology. So by combining the both technology, we have a water engine technology, and JAXA has a big propulsion technology. By combining these technologies, we can make a new product, a new big water engine for satellites, and we can increase market potential.
Who do you think will be the target customer for the big water engine for bigger satellites?
Our target customer is a LEO constellation, a low Earth orbit constellation company. A lot of companies are trying to make a satellite constellation. That means they launch a lot of satellites to provide a service, such kind of Earth observations or communication, internet. So that is our potential customer.
You have research out of the University of Tokyo, which is some of your background. What makes the relationship with the University of Tokyo important for Pale Blue?
I was a researcher at University of Tokyo, and my PhD thesis is a water engine itself. And after I graduated my PhD thesis, we founded our company. And the University of Tokyo keep working for the water engine researches, and they are trying to increase the performance of the engine. So that is a good collaboration for our company.